every time we're doing iCode, what you're going to see is we are going to be using SIMIDs. And that's why the creation of these SIMIDs was so important, but I couldn't explain all this to you before because it wouldn't have made any sense. So hopefully you've been making SIMIDs and you're using them all over the place. And in all honesty, I would tell you, some people have thought, oh no, even though they had SIMIDs, I'm going to go put great big long names, kind of make a path out of the scope and everything. And I will tell you, that might help you for a few minutes right at the beginning, and then it will become, honestly, annoying and almost cumbersome because your lines will come too big. It really tends to be all you want is the SIMID, and that prefix that I asked you to stick onto them will be the key to help you do it. And if you don't even see it now, I will tell you, if you're like the other students, you will, or you're just really probably struggling with iCode, but this becomes so convenient. And in fact, me and Ethan will be able to look at your code and help you debug problems by simply looking at it in this simple format. All right? So the thing to know, though, is even though this is absolutely what is going to happen, in my slides, I'm not going to show it that way. And the reason is because it takes too much room and it's kind of confusing. So the thing I need you to translate is, if I use these lexems, I'm going to use these lexems down here. Sorry, that's not a lexem right there, but I'm going to use these lexems. But it is always using the SIMID. So even when I write B, you're going to know you don't mean actually B, you mean the SIMID for B. When I write C, I mean the SIMID for C. So just know it's always the SIMID, even though this lets you more quickly translate and go, oh, I know what you're talking about. You're talking about B SIMID, C SIMID. That's a temporary variable that was created on the fly. So you can go, yeah, those are created on the fly. Their SIMID and their lexem are one and the same. All right? So notationally, that's what I'm going to be doing all the time. All right? And if I ever deviate from it, I will explicitly tell you I am deviating. This is not the SIMID. And in all honesty, I can only think of really one case where we deviate, and it's because the symbol isn't in the symbol table, but you'll see it. All right. The thing we're going to do is we're going to use something called a quad. All right. This is not something I created the ideal for, but again, I've changed it and done something for us. The concept of quad has existed for all I know ever since they started writing compilers, but actually the oldest compiler book I know of, the Dragon book, talks about having quads. All right. Now, technically, a quad has more than 4 fields, because quad is just saying it's got 4 fields. And the 4 fields they're referring to are these 4 from here to here. So when they say a quad, what they're telling you is, I'm going to be able to have an operator field, I'm going to be able to have an operand 1, an operand 2, and an operand 3. Now, it doesn't tell you much more than this, but generally the whole concept is, if you're doing something like an add, because we're a 3-address operand, we can take, let's change this and make that be Y, that we can take X, add it to Y, and we can stick the result back in X or whatever we call it. And so you can go, oh, it just makes it look more like 3-address operands, because 2 binary operations can put the result someplace else. And that's why they use this. All right. Even though it's called a quad, there is always a label, so you can go, oh, it's a 5-tuple. Not even sure how to say it, but it always has a label. That's not something I had to create and add to it. It always has a label because we're going to need labels. Think of, we got to jump to labels. Functions have labels. Things have labels. We got to get to them. Essentially, they got unique names, which are, again, SIMIDs. Okay. This is something.
I propose pen tuple.
Pen table? There we go.
Pen tuple. Pen for 5, tuple, pen tuple.
Okay, and it's probably actually correct, but now we got to change it because it's going to be sextuple, which actually sounds then like we're trying to be strange, but we got a sextuple because what we're going to add on to it is a comment field. All right, now the comment field was something I started doing, but I'll tell you, this is a place where a student, I don't want to say a student, I can tell you his name was Tim Parkins, came up with the coolest dang idea. Just, it was really cool. But I'm going to explain about it in just a minute, but we're going to have a comment, but this is super helpful. But let me go and explain some other stuff first. All right. There is a concept you are going to have to use. It is not optional. It is not anything. You're going to hear me almost get annoyed as I explain this, and it is because, and it's become less prevalent because I tell students how annoyed I have been with this. This concept is unbelievably simple to implement. And over the decade plus I've taught this class, it has been a common feature people mess up. It was real common in the first few years. And I would sit with people here in my office, which would be the equivalent of sitting with you on Teams. I have sat with people for an hour at a time to debug their code. And every single time I track down this person's bug, they will not have implemented backpatching the way I say. And worse than that, and you'd go, well, people can make a bug. You're getting annoyed with people for making a bug. No, it's not that they make a bug. This is super simple. In every case I've ever tracked down with a student, they can come back and they'll either tell me by the time I find it or something else. Yeah, I didn't implement what you said to do because I found a better idea. That didn't work is what I'm telling you. And they won't tell me they don't implement what I said until I find it. And then they generally will fess up, or I've had people in the middle start going, wait a minute, this seems weird. Well, I didn't do what you said. All right. The last time I started to sit down with somebody, because I had said, look, it always works. It doesn't break. You must have done something that I'm not talking about. And he was like, I did it. I sat and just repeated what I'm going to tell you in a shorter version because he'd already heard it. And immediately he went, that's not what I did. And I was like, so did you misunderstand? And he even fessed up. No, I didn't misunderstand. I forgot I did it different. But I did it different because I thought I had a better idea. So I'm going to tell you right now, and I'm telling Ethan, if you come and ask us to debug or help you with backpatching, our big thing we're going to keep saying is, did you do what we said? Because in 12, 13, 14 years, nobody has ever not been able to figure out how to implement this. They just on purpose changed what I say. I didn't even come up with backpatching. This is a really old concept. And if you go, wow, you spend a lot of time on it, I am trying to save me and Ethan and you a lot of problems for you coming up and going, you are smarter than the people at Stanford, for all I know, who came up with this. Just do this. There are other problems which are harder, but don't try and come up with an alternate solution to this. It is so unbelievably simple, but it is obviously so incredibly easy to break it if you won't follow the instructions. All right, so now for backpatching. What does it do? The concept that's going to happen here, ultimately, is, and you may go, and again, I'm just going to tell you, don't try and make it different. You are going to have situations which will occur, guarantee you, to where you are going to generate a label on a line that has yet to have a line of code on it. And when you generate that label, later on, as you get going through your code, you are later on going to need to replace that label with a different label, because the instruction you're now writing to that line goes, I need a different label here than the one your code, iCode, produced. And the concept is just do a search and replace the label. And if you go, God, I understood what you said. If you've got a label X on a line and you want to stick a label Y on a line, search and replace X with Y. That's all it is. That's all this is. And I'm going to spend all this time explaining more of it to get you to do that. Not because I think you're dumb, but because I've had dozens of students over the year come up and do this wrong and won't even tell me that they won't follow this instruction. So here's everything. Here's that example. You're replacing label X with the label Y. If you go, I just won't stick the label. No, you're going to make everything too hard if you try to change it. If you try to change this where it won't even happen, you're making it too hard. All right? And this problem happens because you generate code sequentially from top to bottom. All right? So you're going to start at the very first quad in the table. I will even tell you exactly what quad to stick in there here in a little bit. All right? But because we're generating code top down, there are situations where we're going to need to fix something, and this is something people noticed a long time ago. Now, the reason I say people at Stanford, because one of the main guys who wrote the Dragon book was from Stanford, and this is where I was first exposed to this concept. All right? So you're going to need to fix code behind you because the new code in front of you changes something that the previous code set up. And this is just the simplest solution to do with it. All right? So it's a super, unbelievable simple strategy. It will happen. If you think it won't, I guarantee you it will. All right? There's no way to generate code without you devising a whole different solution that will be harder than this one to generate code for the examples I guarantee you I will give. All right? So again, visually, what is it? This is what it looks like. Now, the reason I'm putting NA out here, it doesn't matter what is in these instructions. Nothing else matters. It doesn't matter what I am multiplying together. It doesn't matter what the comment is. Nothing matters. I've just got lines of code. I could have a jump statement here. Yeah, somebody's asking a question.
Are we doing this backpatching while we're still in the quad table? We're not actually writing the code to disk yet?
Right, because we're not going to write iCode ever to disk. So this is going to happen right when you're writing out iCode. So it's a process of iCode. The only thing we'll write out to disk, Matt, will be the T code. So the iCode we're going to keep in an array. And if our problems were bigger, like we were truly generating, and there's places where I'll tell you, don't do crazy things like read an entire file. But here I'm going to go, okay, the amount of target code we're going to generate, just keep it simpler. So we're not going to treat it the same way. We're just going to have a great big array. And I want you to keep it in an array just to make it simpler, even though, like when I said, don't read the source code file because people aren't going to ask you, in all honesty, oh, did you write the iCode out to a file and deal with things? Because the backpatching would potentially become really problematic if you went, I've only, yeah, you can imagine, I've got 100 lines of iCode in, and now I got to go read backwards the file, and that's why we just go, don't worry about it. Even if your file was to become, or your array was to become, it won't, 1,000,000 lines of iCode, don't worry about it. You know, like I said, in a commercial quality compiler, we'd certainly worry about it because we would be generating millions of lines of code. All right, so just imagine, I've got a jump statement, and all I'm really saying is it's someplace above it. It doesn't mean it's 4 lines. It doesn't mean it's 5 lines. It doesn't mean it could be 1,000 lines away from you. Technically, I doubt it would be, but it could be 1,000 lines away from you, maybe even more. Technically, I guess it could be 1,000,000 lines of code. We will have a situation. I will explain it to you later, but I want you to even understand your compiler doesn't need to understand why this happens. You can even pretend to be oblivious to it, even though I'm going to explain it, why it happens. But I'm just going to tell you right now, it is guaranteed going to happen. You are going to have a label stuck on a line where you don't have a line of code on there yet. And you might go, that makes no sense. Don't worry, you don't know how to generate iCode. If you did, you would understand this already. All right? So if you go, you're almost nagging. Yeah, I'm nagging because this has been so problematic over the years. And when I tell you I had problems, I am talking about me talking about this just like this. And I am talking about last year, a student coming to me and telling me it doesn't work and being able to track down, oh, yeah, I didn't implement what you said, and I just forgot I didn't do it. And it wasn't an accident, it was on purpose. They didn't do it. All right? So we've got this label right here. It says X. What's going to happen is we're going to go to generate a line of code here. I'm not showing you what the line of code is right now, but we're going to come down because remember, we're just working sequentially through the file. So this is the next line of code I'm going to generate because it doesn't have a line on it yet. I'm going to go to generate it. It had, an X on it. I need to produce it with a different label Y. Literally, just search backwards through your file. Find any place there's a label Y and change it. The way I'm going to describe to you to generate labels, it's going to be unique, and it isn't going to be, you're not even going to have to worry about, like if I just globally search and replace, am I liable to break something? And it's like, no, it just really can't happen based on the labels, the way we're going to produce them. And so you're just going to search back every place. Now, things you could know are, if you wanted to do a little bit of optimization, if I generated a unique label here, it can't be over here. If it is, your iCode generation is already broke. You've got two labels in two different places. And so if you want to search for that, but you don't need to search for it to backpatch, you need to stop iCode generation and go, I have got a horrendous bug. The operators you have cannot be a label. If you found one there, you shouldn't backpatch it. You should stop your compiler running and generate an error message to tell you this isn't like the source code problem. This is your iCode generation is broke. You need to go fix it. So in all honesty, the only place they can be is in here. And if you go, what about even in the comments? I'll even tell you that they're going to show up in the comments. Not the way I'm going to write any code ever, because I would never write anything that even remotely looks like a label name. All right? But so in all honesty, you can go and search everywhere, but there's only a certain number of places. So I beat on that a ton. All right? So it's going to happen. Make sure you do it. Okay. Backpatching is not an optional thing. All right? You can't try to get away from it. This kind of fits with other things, but I'll tell you, if you want to get credit for passing off your iCode, I'll talk about this again, you can't not do backpatching, all right? And the reason is, I'm actually not going to tell you the things people have done, but people have gone and tried to change other stuff as opposed to implementing this simple solution of this search and replace. If me or Ethan find it, we will reject your entire project at the end of the semester, and that means you're going to have to go fix it, which means you're going to have to use backpatching. So backpatching is not an optional thing to do. You can't look for an alternate solution because the alternate solutions that people have come up with, in all honesty, generally make them break, it makes other things invalidated. So I just made it is a requirement to do backpatching because it occurs. And so you can't even find an alternate solution to it. And if you do, and we can see you have it, we won't even accept it. All right? So if you want to get credit for it, you got to make sure you use our iCode, and that's one thing. Now, using the iCode is optional. Okay, you can make up your own. You can't make up a different solution than backpatching. I don't know why you would come up with a different thing for iCode, but you're allowed to. You're not going to be required to do this. I've already done all the work. All you got to do is follow the directions. But if you come up with something different, me or Ethan is not going to learn your iCode. That is not our requirement to do. If you choose to do something else, then you're saying, I don't need your help and I don't need your pop points. So we're not going to learn the alternate solution you do if you choose not to do what I'm showing you here. And it's because it takes us too long to learn what you've done, and figure out. So if you want to do something different, that's okay. But if you want any pop points, you got to do it the way we're saying. And if you go, oh, so I can hide from you, I found this alternate solution for doing backpatching, I'll go, we can see the alternate solutions that we would really, truly reject in your target code. And that's where I've seen them and had to reject people's code. And if you go, you're not telling me, because I'm telling you to do backpatching, and you won't come up with these horrendous, awful solutions, which invalidate, to some extent, your entire target code generation. All right? So here's all I'm saying. We're not going to accept it. So just understand you got to solve this problem. Okay, let's move on to something else. Okay. I've noticed students have questions. Because we're getting close to generating code, I start getting questions sometimes that are not relevant to iCode, but I've discovered if I'll answer certain kinds of questions, it can make people feel more comfortable. All right, so some of those are coming up. All right. So just like I said, this is really a target code issue, but I'm going to talk about it now. All right. That's why, because people sometimes get stuck. They just feel like I can't understand if I understand things. And again, I'm going to stress to you something you need to try and learn to do. If you have that problem, you say, I can't understand something now unless I understand a bunch of things in the future. You need to learn to get over that, in all honesty, and say, if I can understand the problem now, because as the problems get bigger and bigger, you go work on an industry, only your chief architect may understand where it's going. And he may have no ability to explain to you because it may be fuzzy to him, but he is certain he can build it. And if you go, but I can't work on the project unless you can tell me everything I'm doing, then the truth is they will simply get rid of you and find somebody who will do what they're being told. So you can't always feel like, I have to have from the beginning to the end an understanding to start on the thing I'm doing now. It's no, you need to understand what you're doing now and start making progress. And it's the same thing I tell you right now. If you wrote the lecture without understanding the rest, you can see how it fits. If you'll start working on syntax without understanding semantics, it will work. Start doing semantics, iCode will fit. All right? And what I'm telling you is target code will just flow out of this. All right. But here's the issue. All right? If we look at something like this, x plus y, what I'll let you know is we are going to need the address for both x and y when we get to target code. Whatever that means, however we compute it, we are going to need the address for it. And we are going to need the value for both x and y, and hopefully it makes sense. I got to know the address to know where to look, and then I'm going to find the actual values, and I'm going to add them together. If I look at something like this, now I could go through dozens and dozens of examples, but I'm going to show you this. In this case, I am going to need to know the address, again, of both x and y. But all I need to know is the value of y. And if you go, I would have known that. Okay, this has been a question I have gotten that just almost makes, and it's not the way they ask it, it is, this is what it comes down to. Okay, now that you know this, forget it. just go, he's told me, he's explained it, forget it. It's unimportant for right now. It has nothing to do with anything I'm explaining to you in iCode. It is just to get you from quit worrying, how am I going to make this work? How am I going to get addresses? We are not going to deal with addresses. We are not dealing with values right now. We are dealing with iCode. And if you go, I don't understand how this is going to work, promise you that will come out in target code. All you got to understand is iCode. We don't need addresses and we don't need values right now. We need SIM IDs. All right. So now this was a big problem. I've looked at other versions of intermediate code. Can't remember exactly what was described to me, but it was probably something like out of the Dragon book. And generally, at an undergraduate level, maybe even probably for some people, well, actually, I was a graduate student, probably in many graduate classes, they can't deal with indirect addressing because almost no books address how to do it. So they make their compilers unbelievably simple to make it to where they don't really have to deal with issues that come around indirect addressing. And I wanted to solve this problem. It was actually when I was a graduate student, getting my PhD, I wanted to solve it generically. It took some doing, and I came up with a solution, and then I got it better when I came here. And that's what I'm going to show you about. All right? So what I ended up developing was 2 instructions that are intermediate code. I've never seen them anyplace else. My guess is if you ever see anything like this, somebody heard about what I've done. I'm just guessing, particularly if they call them this. But we're going to have an I-code instruction called ref, thinks that's the operator, and we're going to have one called AEF. We will go through how these work, promise. I'm just telling you, this is what it's going to address, all right? But the thing that happens here, and this can affect some of your previous code. This is one of those things where I'm telling you, I asked you to write your code one way because it was simpler. And now I'm going to ask you to go back and make a little change. And in all honesty, if you freak out about this, then you're going to be freaked out about the entire project. This is a super simple little change. What this ref deals with is literally when we have stuff that looks like that. Okay, there's a dot in between there. And the AEF deals with something, and I'll almost use the same stuff where we've got an array. So it's when we're referencing an object. Now, try to remember, that's not the same thing. And you might go, but there's a dot. It's like, it's not the same thing. It's not the same thing. We're talking about when we're referencing an item. This really has nothing to do with that except they reuse the dot. All right? And you go, I think it does. And it's like, promise you it doesn't. If you forgot what I was talking about in the last class, it will become more explicit because we're going to get into it. We create a temporary variable in semantics for this. All right? Call it like T1. You're going to see this. We create a temporary variable for that. We can call it T2. What we're going to do, I'm going to show this again. We're going to change the prefix on these temporary variables from going to T. We're going to change them. And that means you go change the code. You don't, go change it in the symbol table. Write it out and change it to an R. So this would be R1 and R2. And in all honesty, what I'm going to tell you right now, I'll try and explain more of the detail later. This is going to fix all the problems around indirect addressing. And you might go, that makes no sense. And it's like, I guarantee you it does make sense when you understand the problem. But I've got to teach you more before I can explain why this fixes everything. And for some of you, you won't even understand it until we get to target code. But I'll promise you, it fixes everything. And it was so cool that this has simplified intermediate code generation greatly. Now, some of the simplifications aren't just this. It's the way I came up with my intermediate code, but this is the single most different thing I know of that I've done. All right, there's other things I've done related to functions, but I-code generation has been so simplified that I've had multiple students, and I was mentioned the other day, but I'm going to remind you, I've had multiple students finish this in a week. I've actually had students, they claim, and there's no reason for me to not believe them based on who they were, they have finished this in a single day. What I would say is don't plan on that. Don't go, I'm going to purposely procrastinate and get this done a day. Because what I will tell you is nobody who ever planned to get it done in a day, to my knowledge, has ever finished it in a day. It is students who just sit down, understand basically what's going on, and then start working on it. And a couple hours into it, they start going, oh my gosh, I get it. And the first student who ever said they finished it in a day, literally was, they didn't sit down to finish it in a day. They got toward lunchtime. He told me, my wife kept walking in and saying, you want to eat lunch? He was like, I'm almost done. Let me, just leave me alone for a little bit. I'm going to get done. He finished it. He came out and said he was done. His wife said, you're done with the compiler class. It's all over with. And he was like, oh, no, that's not what I meant. I'm just done with this phase of the compiler. All right? So don't plan on it. Now, what I'll even let you know ahead of time, I'm going to give you 3 weeks to get I-code done. So it's a place where some of you can catch up. But don't start procrastinating. Just know I built the class with, if you want to think, some slip based in it so you can try and get caught back up. Still going to give you 3 weeks to do it. Semantics, like I said, that's a hard 3 weeks. I'm giving you 3 weeks to do it. So you need a push. This is going to get easier. All right. Now, when we look at something like a move statement, think of that code. The code we're going to generate is going to look like this. Now, remember, that's a SimID and that's a SimID. And hopefully you can go, oh my gosh, I can read that easy. We're moving Y into X. All right. You can go, that is super simple. That's literally going to be the code we're going to generate. To help you even understand this a little more is if you go, when am I going to generate this? I'd say, think about it. What do we do semantic? We do an we do an I push followed by an I exist here. We do an operator push. Then we do an I push followed by an I exist. Then we come to the end of the line and we do an end of line. All right? Those of you who've done any semantics, who've started even that one thing, those of you who just understand this, you understand exactly what I'm describing. Those of you who've implemented this, you really, really get it. Okay, when you pop that operator off the stack, you check is the left-hand side an L value, and then you go, can Y be assigned to X? When you know it can, to some extent, when you are finished evaluating that operation and you know it works, write that line into the quad table. And hopefully for some of you, you just went, oh my God, it's really that simple. And it's like, yeah, because you're going to see most things, it's really this simple. And just like I was telling you, and Ethan was explaining to you how iCode just flows out of semantics. When you get semantics to work, so don't try and do iCode in the middle of semantics. Get it to work, verify it, test it like crazy, because it's going to take you a lot less time to do iCode if semantics work. If you try to do them at the same time, you will be fixing iCode and semantic code at the same time, and it'll just slow you all down. If you get semantics to work, iCode just basically flows out of it. Easy. All right? Now, we were talking about this special kind of reference variable, so I'm going to specify that because we're going to come back and look at lots of problems, all right? There's 67 slides I got to get through here, so don't think, oh, he's going to be done in 5 seconds with iCode. No, we're going to look at a lot of examples. All right, so if we had this reference here, so I'm not going to go through everything because you're supposed to know semantics, but when we did semantics on this, and we do the R exist, we generated a temporary variable for that R exist, right? And hopefully you remember, we did that. I explained it. Generate a temporary variable, and that temporary variable is in the current scope. And again, to remind you, that temporary variable has the same data type as what B was, all right? That has a T right there. It's coming from a reference. What you're going to do is you're going to quit using the T and you're going to make it be an R. And again, I don't mean generate a T and then go update the simple table. I mean change it. Change the prefix. Remember I've said use a gensum routine. And if you go, I didn't do that, I'd go, then you may not understand what I'm talking about. You had a T, change it from gensum to generate your SimID R. And if you go, you're using lowercase and uppercase, I don't care. You know, it's just, I find it easier to write lowercase t's and I find it easier to write uppercase r's. But change it to an R. This is going to fix a monstrous, guarantee you, a monstrous problem that exists with intermediate code that I've never seen anybody figure out how to fix. And this fixes it. All right. And so later on, when you got the move statement, you're just going to be moving R1 into X. And I'll guarantee you we're going to know how to generate tar code for this. But that's all you got to know for iCode. We're going to do that. All right? Here's everything I just explained to you. All right? Now, if it ends up on the other side, the same thing would have happened. We would have generated some temporary variable. Again, it ain't going to make any difference. It's on the left-hand side or the right-hand side. because you should know syntactically, semantically, it uses the same code. It's going to go through an argsys. Just make it be an R. Now, technically, the reason that I used R is because it started out as I used this to solve a reference. What I figured out is once I solved the reference, essentially something like x of y, I figured out it works on arrays. I'm not going to show you the array right now again, but when we get the array examples, I'll start showing you. But you can think of, again, if I have that, we've talked about there's supposed to be a temporary variable for it. I will guarantee you it needs to have a prefix of R. If you don't do it, it will be hard. And if you go, I'm going to generate something different than an R, I'm going to call it an A, I will guarantee you it will do nothing but make you write more code. Because knowing it's an R is more than enough. And if you want the reason why, I'll give you this. Yeah, do it over here so I have room. And if you go, you have been telling us since last year in y'all's case, last year, that's the hardest problem we're ever going to solve. It is. It still is. It never, ever changes. It's a base address and an offset. That's what this is doing for us. All right? So if we have a chain of things, all right, notice I've got a dot thing. Some of you come in and ask me to pass off syntax. Oh, to the person who asked me about how many people have passed off syntax, I won't give, I could give the specific number, but I'll tell you, Ethan has finished as many as I have, so we're more than doubled today, but technically he's been doing it for days. But when you've got dots like this doing references, all right, you're going to generate code that's going to look like this, right? I'll just promise you, we're going to kind of look at examples in more detail, but it's going to generate code like this. Because you should know, I generate a temporary variable for that, and then I check if this can be off that temporary variable, then I generate another temporary variable for that. And even though this is the same side, I come over here, and I've said, don't worry about it, you'll generate another temporary variable, then another temporary variable. All of these are going to change to R's, and you might go, but this is the same as that. I'm going to optimize it. No, don't. First off, you will get no credit for doing optimizations, and I'm asking you not to. So if you want to not follow directions, you would do it. Please follow directions. You're not going to get any credit for doing this. If you try to optimize this code, you're most likely to break it. And here's the other reason not to do it. This code would not be optimized in iCode generation. There is an optimization called iCode, intermediate code optimization, which would optimize this. And to optimize it is almost trivial there. But to do it here, you have to change the entire strategy on how we're generating code, and you have to convolute it and make it more complex, which is the thing I always tell you. Generally, a pure optimization makes your code harder to understand. It may make it run faster. The code you would be making harder to understand, in this case, would not be the assembly code you write. It would definitely be the iCode generation that you write. Don't worry about unoptimized code, all right? Don't worry about it. You'll see even more reasons why I explain when we get to T code, but the truth is you don't do optimizations in the middle of code generation like iCode and target code. So I will explain a little bit of a difference there in target code and why we don't do something they say to do, because it's an optimization. But there's optimization phases that follows this that fix all the unoptimized code. And they do a great job of it. And they're generally, most of them, and even to fix a problem like this one is really easy to fix. All right. Now here's something about chain of pointers, because this again is more of a target code, but it can become confusing to the point it's worth explaining right now. Because I'll admit, when I was doing my intermediate code is when I started thinking, back when I was a grad student, how am I going to make this work? How am I going to make this work? And I figured out, oh, this thing I've done makes it work. All right. So imagine for this little hunk of code, I've generated these 2 lines of I code, right? Hopefully you kind of followed what I said. Imagine I generated a temporary variable here, but now that one is called simply R1. I generated another temporary variable for the whole thing, and I'm saying that's R2, and they're both off of references, so you can go, oh, that's it. And you may notice I'm not talking about the comments yet. We're going to get to that in a minute. So that's what we got. Let's look at it, if you want to say, symbolically, graphically, what's going on. The most likely way this is laid out is I've got an activation record. It could be different, but we'll start with this one because that will pretty much answer your questions. I could have a pass parameter, a local variable that was A, all right, in here. We've got an object, doesn't matter what its name is because we don't even know what its name is, but we've got an object that we're referencing from A that has a B in it. We've also got some other object out here that's got an X and a Y, but that's from our previous problem. But I'll just go, there's an X in it, but if we went back to the previous problem, we'd go, oh, it's got an X and a Y, so it's got an X. Remember, address offset. Yeah, I'm going to keep telling you, it's the hardest problem we got to deal with. Guarantee you it is. It is. That's all this is. Okay, if you remember from last semester, that's a base address. To get to A is an offset. Okay, you've already solved that one, but I'll pretty much guarantee you that's when you understand that. If you've got recursive functions work, man, you are so far along the way. Most of the stuff all kind of works the same way. It's a base address and offset. The only thing that changes is it gets hard sometimes to figure out what is the base address and what is the offset, because sometimes they're not so obvious. Sometimes we got to compute them. Sometimes we got to find them. All right. But if you think what A is pointing at is the very beginning of this object, which means that is a base address. There's an offset that goes to that. Remember I just talked to you about computing these things before you get to here? Right? So there's an offset there, even though that's a base address. If you look at B and think about what B has to be, it's a base address again. And then there's an offset to X. So everything is a base address plus an offset. Now I'm going to erase this so you can see it easier. When we generate R1, it's a temporary variable. What I will tell you will end up being, you can go, I don't see it right here. It doesn't matter. That's a target code thing. What this means in I code is I am pointing directly at B. I've basically taken my base address, added my offset to it, and stuck it in there. That does not happen in I code. We are not building a virtual machine that runs this. This conceptual just says this is what is going to happen. That's what we're going to do in target code, but it conveys this message to us. Right? If we look at what T1 is doing, it's doing the same thing, saying I point directly at X, which then allows us, if I assign two things between each other, I'm simply assigning between R1 and R2. I'm using R1 and R2, but I am pointing directly at what I want. And if you go, but there's another problem in here, I guarantee you I can show you how to fix it, but I will not talk about it until we get to target code. All right? But this solves the problem. And if you go, God, this seems simple, then you'll do it, and it will be simple, and you'll be able to get target code for this. All right. Add comments to your quad. All right? Oh, my God. This idea that Tim came up with was so incredibly cool. I wish I could claim credit for it, but I can't. Tim did it. Tim came up with it. I'm certain his name was Tim. I'm certain it was Tim Parkins. The difference is here. I'm pulling up some different things. one of the things we're going to be dealing with. So this was such a cool idea. It is, because I had done some stuff to try and deal with this a little bit, but not as cool as Tim came up with here. All right. We're going to have a one-to-many relationship between lines of KXI code and lines of intermediate code we generate. We also, not only is it one-to-many, we also want to be able to relate lines of code back in our program to the intermediate code. And I'll tell you, we'll do something, I'll show you how to relate, but you'll probably get it. It's going to work the same way, how to relate intermediate code to the target code. Because one of the things I've told you, generating I code and even target code, if your semantics works, tends to be what students think of the easiest, but testing it is hard. One of the things that makes it hard is to relate. You've got an I code, you've got a KXI file. It goes to a lot of translations, and then you can think of, we generate I code. Then we go through more stuff, and we generate an ASM file. One of the big hard things is looking at a line of I code and going, what in the world does that relate back in that file? Looking at a line of code over here and reading it back and go, what does that relate to in here? And how does that relate to a line of code back in here? And the solution that Tim came up with fixes that in one simple step. All right? It is super cool. It is so cool. I've noticed two things over the years since Tim came up with it. Now, it didn't make these students different, but I've noticed two things. Students who finish their compiler early, and I mean early, tend to have two things in common. First is they don't procrastinate. That's always been true. But the second thing I've started noticing over the years and years and years of this, they put these comments in their I code. In fact, because Ethan helping me is a new thing, and other TAs are a new thing, I can go back for 10 years of doing this by myself, if not more, and go, I can actually think of only one student who actually got done with her compiler early that didn't have this once the concept was conceived. So the thing we're going to do, and I'm going to show you how to do it, and I'm going to explain some more about it, but the truth is what we're going to do is we're going to take the line of KXI code. I mean, this is just such a brilliant idea because it's so simple. It's so easy to follow. We're going to take the line of KXI code and we're going to write it as a comment right next to the first line of I code that we produce to deal with it. But then what we're going to do, we're going to make the next lines underneath it all be blank. So when you're looking at your I code, and you'll do the same thing, you can think, oh, I told you it's going to be an array, but you'll just dump it out to a file just like you do your simple table. You'll be able to look at it. That's part of the reason you want it to be short. And you'll be able to go, here's the line. Here's what I generated for it, but everything until I find the next line is related to this one. So think of the first thing I got to do is an add. The next thing I got to do is an assignment. Now, there will be times where the difference between here is really big, and what you don't want is this line repeated over and over again. You might go, well, isn't that easier? And I'll go, no, it makes it hard to read because you need to find the first line. And so if you'll do it exactly the way it was designed to be done, you will have one comment, and then until you see the next comment, you'll go, everything from here to here relates to that piece of I code. Sorry, that piece of KXI code. You can go, oh my gosh, you can find it so easily. Now, I'll tell you another reason this has become so easy, that when we are passing off your I code, if you want pop points, you have to do this way because it is so burdensomely slow to do it any other way. Me and Ethan just won't have time to do it. So if you come to us, you got to use these comments. And it's not hard to do, all right? Again, I'm just telling you, it's super helpful. Now, here's what I did. I didn't want to take credit for this in any way, shape, or form. But the truth was, when Tim came up with the solution, I asked him to document it and explain it to me. Because honestly, I didn't think of how he did it. I wasn't really trying. I just was so impressed that he did it. I said, hey, will you write up something and tell me how you did this? He graduated and everything. He didn't write anything up. I had students after him. I told them, hey, this is what Tim Parkins did. I had other students start doing it, and I would ask them, hey, will you explain to me, exactly what you did? And the truth is, students would get it to work, but I think a lot of students actually didn't know how they got it to work. And in fact, some students kind of worked, some students didn't work as well, but they still had the comment, basically the way I'm describing, but sometimes it would get off. But it would be, like I said, you could normally see it helped students get done faster, easier. It helped them debug. All right. Last year, I ran a contest. It was a super simple contest. I gave extra credit points. I asked students, will you figure out how to make this work? Because when we went to the grammar being LL3, it made generating this harder. It broke it. It didn't work as easily. All right. There was I used to describe a simple solution. So I did sit down and come. It made a super simple solution not work as well. So I asked people, compete. The first person who came up with a solution for it was going to get credit for it. And the truth is, Bryson Wiggins and Cameron Clay from last year came up with a solution at the same time. I mean, it was so close to each other that it was a tie. One came in, hours or a day earlier, but they both had it at the same time. So I asked them to sit down together and write a document and explain to you. And if you'll go into the document, into this one, you will see their write-up for how they solved this problem and how they explained it to you, being students, explained it to you. And I'm giving full credit to these guys. Now, what I want you to know is they didn't conceive it, but they documented it. And in a way, I want you to think back to 4380 when I told you about Eckhart and Munchley. They solved the problem and didn't bother to document it. So who got credit for it? Von Neumann. All right? So now, if you want to call this the Bryson Wiggins, or if you want to call this the Wiggins-Clay solution, it would be absolutely fine, because even though somebody else came up with it, he didn't take the time to document it. Now, what I'm going to do, right here, I've already told you these things. And I've already told you the only way we can look at your iCode, because it's so easy if you'll do this, and so hard if you don't. Essentially, we really won't look at your iCode if you don't, because you're saying, I don't need your help, right? So put the comments on your code, exactly what we're talking about. Now, again, you can't use anything but your assembler and your VM. You can use different iCode if you want, but you cannot use something different than your assembler and VM to run, all right? Now, this honestly is a simplified version of what the Wiggins-Clay, if you want to call it, comment solution is explaining to you. Because I went through it and looked at it in detail and went, oh, there's a simpler way to explain. But they've got a longer explanation, and they've got a really crazy, I can tell you, this was Bryson Wiggins' example, this crazy long example. He came in and showed me, and I was like, holy mackerel, that's a great example, because I forgot how long it is, but you got like one line of code, and it generates, team spaces in between them. But this is what's going on. So this is what you're going to want to implement. Guarantee you want it. If you say, I'm going to get done faster if I don't do it, no, you won't. Not unless you are perfect, beyond perfect, beyond perfect. And even then, if you were perfect, you would do it. All right? So this just goes back to your lexical analyzer. Okay? Your scanner thing you built. You read into a buffer a line of code. There's a hint. There's a line of code. All right? We got a token 2, a next token, and the current token end up happening. So we could end up generating a line of code just like this for just that addition statement, but that's the very beginning, because think of it semantically. The first, I said the addition, but it's the multiplication. I circled the wrong one. For this multiplication, there's the first thing to happen. Then we're going to do an add, and then we're going to do an assignment, and all these things happen because of that one line of code. So we don't need each one on each line. What we need is to see what the 1KXI line is, and then all the I code in this will be super simple to follow. All right? Really don't do it any other way. I guarantee you, this is the coolest, best solution. I've seen people modify this and munge it and make it something that I can't read, my TAs can't read, and in all honesty, if I ask them, what does this really mean, they'll almost go, well, I thought it would be more helpful this way, but yeah, I can't really figure it out. All right? So do Tim's solution, but do Cameron and Bryson's solution. All right? So we got this in a buffer. What you need to build, this, in all honesty, these two guys did this independently, but they came up with the exact same solution, which is what was cool. When they sat down, they had the exact same solution. They've both done it the same way. There are harder ways maybe to do this, but none of them work any better than this. And I wouldn't explain anything else. So if you go, I'm going to find a better solution, sorry, I ain't going to give you extra credit. I'm not going to change this. This is super simple because I can explain it simple. What you need to build is like a hash map. Think of like a little symbol table, hash map. The key is going to be the line number that you read. All right? Remember, you have a line number associated with each line in the buffer. What you're going to do is you're going to copy the line when you read it into the buffer. All right? You know when this happens. When you read it into the buffer, you're going to copy it into this hash map with the line number that it was on. Now, you can go, what would this be? Okay, this could be a line that was read before. It could be blank, or it could be something else that I'll explain in a second. But it could even be blank. Just put it in there. Don't make it be fancy or different. Just rotely copy it in there with the line number it was at. Now, what you're going to do is you're going to grab that source code line, and you're going to copy it over here as the comment when you generate the first line of code. And if you go, how do I know I'm generating essentially something for a line of code when I'm generating stuff? All right, how do I know when I'm doing things? Well, the simple thing to tell you right now, you can figure out if it ever changes. We see operators here. Remember, one of the things I've told you is when we're generating error messages, we need line numbers on them. So your semantics always know what they're looking at, and there's a line number associated with it, which is normally just the token, and you can go, we can generate errors with line numbers. That's what also makes us generate code. We've got line numbers. You know what line number you're on. The first time you generate a line, but honestly, what's going to always happen is every time you generate a line for any line of code, figure out what line it's on, go into the symbol table, and copy it down here, just like what they're showing, right? Now, here's the cute little fix, because we want it to be blank every line after here. What you do, the minute you copy it, right back up here, a blank. Right over it. Get rid of it. So now what will happen if you generate another line underneath here that is for the same line? It will go up here, grab that line, but it's blank. It will write it down here as a blank. So literally, every time you're writing. Now, this was a solution I had. The thing was I didn't do to fix this solution off. What they figured out, hey, just keep up with these line numbers this way. It's super simple, folks. So copy your entire buffer the minute you read it into your symbol table with the associated line numbers key. Every time you write a line of code into your quad table, look at the tokens. Figure out what line number it's associated with. Go into the symbol table, find that key, find the associated value, and write it out. You can go, well, what if it's blank? Great. Don't make your code any more complex than it has to be. Write it every time. But then every time after you write it, put a blank on it. You can go, but I don't have to do. Don't worry about optimizing right now. Do that later. Just do this, and you will end up with this cute little solution. All right? Now, let's really get to converting. And I know I'm ahead of you. Everybody's working on semantics, or everybody's done with syntax is working on semantics. The rest of you working syntax. Remember, it's okay to be a little bit behind. What you don't want to do is get really far behind. So work hard to get caught up. Work hard to get to semantics, because semantics is hard. All right? Letting you know. Okay. Things like these types of things, we don't generate any code for them. I'll let you know up front. We don't generate any code for them, right? You will not see any I code. They are here in the grammar strictly for doing syntax. And you might even go, I haven't seen these except as keywords. And it's like, exactly, because I switch the grammar every year. Sometimes I use these options. Sometimes I use these things because I implement the switch. And sometimes I implement the multi-threading. And I flip-flop back and forth. And I've already thought of a change I'm making for next semester that's going to be different than anything else I'm going to add. And I'm going to add new keywords. But you're not going to generate any code for these, so don't worry about it. In fact, there's really no semantics. There's a little bit of semantics for these, but you don't have it this year. All right? So you're not going to find anything explaining those. All right. Now, we will look at these in more detail. But here's basically what's going on, and hopefully once I do a few of these, in fact, some of you are probably looking going, oh, I get it. If you've got a line of code like this, think of, we generate a temporary variable. So right now, I'll just say T1. The I code you're going to generate looks just like that. You're going to, now remember, that's a SimID and that's a SimID. This was a lexeme and that's a lexeme. So what we're going to generate is essentially a SimID and a SimID, and that's a SimID. So everything, so the I code is just add A and B based on their SimID and stick the result in this temporary variable that I created during semantics. All right. I show this one. Now, that would be a constant. I'm trying to think. I don't know how many students I've ever had do this, because you don't need it. I created it in case people needed it. In all honesty, I'll try and exaggerate and go, I think 3 people have ever used this instruction. Technically, I'm not sure anybody ever has. But I created it because when I was creating the intermediate code, I didn't look to just create it for KXI. And in truth, most of these statements were created when I was a graduate student working on my language L. I just refined them and made them better when I came and worked on KXI. And I did. The ref and the aref were not what I worked out. I had a solution more like what you would find in a god-awful dragon book kind of thing. It was better, maybe a little better than what they did, but it was still, it was a crappy solution, is what I'll tell you. The aref and the ref were a much better solution, and I didn't do that till I got here. All right, so you can see add, subtract, multiply, divide, they're all the same. If you get this, you're going to go, oh my gosh, when I get to this, this was just like when I did syntax, and then when I did semantics, and then when I go and do intermediate code, I can almost do this. When I get one to work, which is probably that one, you'll get all the rest of these to work, because you're going to go through almost all the same code. And I'll go, yeah, this is how you start seeing how you can get this thing done in a real short period of time. All right. And again, we're going to look at a lot more examples, promise you. This is not the end of showing you these. All right. Now, if you've got something like a less than or a greater than, what are you going to generate? The I code looks like that. Remember, SimID, temporary variable. And again, these are T-based. Don't mix your R's and your T's. If you go, but it doesn't make any difference. I wouldn't have introduced you to an R-based variable. It doesn't make difference. Keep them separate, because we will deal with them separately. They're all on the activation record, so that's the same. But what we're going to do with them when we get to target code is really different. You can't mix them. The only R-based variables come from a reference, or when we're doing essentially indexing into array, which is the AEF. All right? So again, that's just a temporary variable. Here's a greater than. Here's a not equal to. Here's an equal to. Notice what we're doing. You're going to go, those things are coming off the operator stack. They're coming off the operator stack. Exactly. Here's a less than, equal to, a greater than, or equal to, and you just go, oh my gosh, when I can get add, subtracts, I can go do all these. Think these are all things in expression C that you have semantics for, because you only do this when you do semantics, so you ought to know. You can probably envision in your head, those of you finished syntax, which there's like 14 of you already, you could probably envision, I know exactly where I'm at in this code. All right? Well, actually, finish semantics. No one's finished semantics. Those of you who finished syntax, but you can still probably envision where you're doing this. All right. So think of an and is really the same thing because you're going to figure it out. That's the temporary variable. So here are the two things I did with an and. Do I use an and like that, or do I use an and like that this year?
What you got down is correct.
Oh, okay. So, in all honesty, if it wasn't, what I'd say is just change it in your mind. You know it's an and or. Because like I said, I switch so often from year to year, I don't even know which ones I'm using. Okay, so we look just like that, but you can get it. SimID, the temporary variable generated for that hunk of code. There's a temporary variable for that. It's going to be a Boolean. Yeah, it's going to be a T-based variable, and, or you can go, oh my God. Yeah, I hope you just go, this is super simple. Now, if you'll notice here, I don't show you necessarily the KXI code here, and here, because it can be more complex. We'll see this in the examples. But we're going to have a branch false, and it's going to say, literally, that's a SimID. We're looking there based on it being essentially a Boolean value. Do I jump to that label? There's also this branch true. Now, I'll give you a hint that I've noticed, and pretty much everybody else will notice when you go. Again, I did this when I was making the intermediate language. I designed the language first and then figured out, does it solve all my problems? That doesn't get used. I know it seems like you would, but you don't branch when it's true. It just doesn't happen, all right? You'll figure it out when we get to it. But it's there for coverage because, in all honesty, I've sometimes tried removing these things and I get as many questions on why don't I have it? So I just leave it there for clarity. You'll see another one here in a second. So we're going to have a jump, and you can probably imagine, yeah, I'm going to have to jump around. Now remember, what we're going to do is we're going to turn I code into ASM code, but it's basically it's CS4380 assembly code. Some of you could look at these and go, that pretty much is 4380 assembly. That pretty much is, except I don't have an extra variable stick stuff in, and that jump statement is the exact same one. Yeah, this is why hard code. You don't need to be worried about it. It's going to flow out of intermediate code. And again, we'll cover this in, if you want to call it, excruciating detail. We're going to have a push command, and what I'll tell you, it's pushing to the runtime stack. All right? We'll show it when we get there, but we're going to push stuff onto the runtime stack. We are going to peek onto the stack, but the peek is not implemented when we really get to it the way you think of a peek. But the only reason we're going to ever use a peek, you can think of, remember when we had function calls in 4380, like the recursive function calls, they returned a value? We went and looked at the stack in a certain place and we grabbed it. We're going to use this piece of I code to represent that. And then we'll just implement that special way of doing it. And you go, what about the pop? Never, ever, ever, ever use it. It's only here to keep people from asking, why don't you have a pop? But we're never going to use it. Don't use it. It would be a horrendous ITIL. And it would make your code super hard to write. All right? Now, these I'm going to explain a little bit about, but again, we're going to look at more examples. These are things, some of the I code, like I talk about, you might find in somebody else's I code. Because they're kind of the same. Now, one of the differences I've done is you'll notice every time I'm talking about something, I go, it's a SimID, it's a SimID, it's a SimID. That part I've also not ever seen, all right? Maybe somebody who's done it, I've never come across anybody doing this. Figure out, reference what's in the symbol table. Again, this is what makes it super simple. We're not talking about registers, we're not talking about addresses, we're always referencing the symbol table. It's life, the universe, and everything. It is Big Blue, it is all these things, it's all knowledge, it's the Oracle of Delphi. The symbol table knows everything, all right? Some of the instructions I have generated are really unique, not just the attribute of them. Again, these right here are nothing I've ever seen anything like, right? Frame is what we're going to use remember we have an activation record, but it's also kind of frame, right? Frame is something we're going to use to start building up the activation record. I'll even let you know what it's going to do is it's going to build this part of it. We got a return address. We've got a previous frame pointer. Now remember, it doesn't actually do it. It just represents that's what we're going to do. And I said we're always going to have a this parameter. That's what this thing is going to do for us. All right? And what I'll let you know, the way it's set up is the following. F is the sim ID for the function, right, that I'm going to call. X is the this parameter. So quickly, and we're going to come back and look at examples. So you follow this, great. If you don't, we're going to come back and look at it. If I've got a function that looked like that, let's even go Y. Then the way the frame would look would be frame, the sim ID for F, the sim ID for X, because that is the this parameter. And if you remember from the other day, I showed you this, and it's going to be, oh, so by the time this is done, now it's one in target code, but what this means is I have found my return address. Oops. I have set up my previous frame pointer, and I have put this out here. What is this? It's the value that's in X. We crammed it in there. Now, you might go, what if I do something like that? Then I would go, because we don't have any true global functions except for main. If I had a function like this, and you'll go, but you didn't deal with Y. We'll deal with Y when we get to it. All right? I already showed you push. That's what we're going to deal with. If I'm doing a function like that, I would have to be inside a member function of a class or inside of a class doing a function, which could also be a constructor. So what would it be like? I could do that. The frame I would generate would look like this. Oops, frame. The sim ID for F. And you can go, but I don't have anything in front of this. It's implied. It's this. And if you go, the sim ID for this, remember, the lexem and the sim ID are the same thing. It's this is all you're going to type in. And again, I'll show you how to do it, but that's what's going to happen here. Now, these things are some of the most complex ones we have. Now, for some of you, I'll go ahead, if it helps you, and I'm going to give you the first 3 lines. Now, I'll wait a second here. We're going to have a call command. All right. Call is what literally like jumps to the function and does some other things that you did right before you call. All right. So we're always going to have a frame for a function call paired with a call. All right. And it actually jumps to the function. In between here is where we're going to deal with the pass parameters. And I'll just let you know those are pushes. All right. From an I-code standpoint, so it's really easy to look at a function call. There's more things that go on in here, but I'm not going to get into the details of target code. But you can think of jump to the function call and does some other things that we needed to. All right. Now, a return address or a return statement that looks this way is whenever I use a return in my code. So it would be a return, but it looks like that. I'm not returning anything. We're going to use this version of return to explicitly distinguish between a return that's turning something that looks like this, where that's a sim ID pointing to the symbol table, versus that, which means I'm just returning from the function, right? Here, I've got this func here. This one's kind of special and different, right? This and this one have something in common. So it always happens to this one. Right now, off the top of my head, these are the only 2 I-code instructions that you will generate when you're not even doing what looks like an operation. All right? And we'll get to those later because I see I'm about to run out of time. But this one, because I'm on it, happens every time I see a function declaration. So think of a function declaration could be like that. when I see I'm declaring a function, I need to generate this for the SimID of the function. It's because we got code associated with it. But we're going to stop right here, and we'll come back, and we'll talk about this next week. Any questions? Because y'all were amazing quiet. Remember, you can always interrupt me, and in fact, I would have expected you to, but nobody did, so I wasn't going to stop. But any questions? Any questions? Still no. I don't know if that means I've lost everybody, or everybody goes, this is so easy to understand.
I have a question that's,
Go for
I don't
it.
know if it's super relevant. I'm just wondering, right? Is it possible to get a no reference exception with KXI?
It's possible to get, it depends on how you want to think of it being done. KXI is not going to check for that. It's going to be more like C in that way, which means you can get something more like a segmentation violation. Because remember, KXI is like a combination of C++ and C. So in this way, it's going to work like C. It's going to work as fast and do what you want it to. But if something isn't set, you're just going to go off into la la land and start implementing. We're not going to have code, which would be actually, and it actually would be to make this work, it would be assembly code that would be checking for it.
Okay.
But, so it kind of depends on which way. If you mean like a true exception, no. If you mean, is it going to generate an error? Yeah, but it also, if it can find something and go, this looks valid, it'll just keep running. And it's the same thing like accessing an array. We're not going to check that you're inside the bounds of an array. So don't write code that won't, but any example I gave you won't have a problem. But you can think so
curious.
just like C in that way.
So it's like if you insert no into a place and then you try to like reference into that, then you might end up, like reading code in a different area that you weren't intending.
Oh yeah. So that concept that you could jump off and start reading all kinds of crap, yeah, it happened. You can do that in KXI. So to some extent, it's not going to try to find your programmer bugs. It will find your syntax and semantic bugs, but it's not going to find your runtime bugs for you. You're going to have to find those yourself in the examples you write. Or don't write them.
Okay, thanks.
But I'll give you some ways to actually generate. I can explain real quick right now. I'll give you some simple ways to generate like some rather complex KXI programs without really having to write any code. And literally will be take programs that you got that are written in other programming languages and start compiling them in KXI. And when you've got syntax and semantics, don't just turn it into a KXI program. You can even go get like a lot of your programs, 1400, probably in 1410. If they're really like they have inheritance, you'll really have to do some finagling. But if they just got objects, man, you can just compile a program from 1400 to 1410, maybe even from 2420, and they'll just, if you just keep fixing everything, don't be like, I don't know how to fix this. Look at it and go, oh my gosh, I can just write the lines. Because literally, that's how I generate examples for y'all. I write a Java program. And then I make some changes to it and even break stuff and things like that. But that's how I write examples. I write a Java program, make sure it works, know what the answer is, and then I run it. So when y'all run your programs for me, I know what the Java program said. Your program has to get the same values out. And they do. They won't generate anything different because it's a combination of Java and C++. More questions? All righty.
I have a question. Can you hear me?
Yeah.
So I have a question about the R. So do I need to create R instead of T anytime I need to create T?
Anytime, yeah. So anytime you're doing something that looks like that, there was always a temporary variable. Just change that T to be an R1. And the same thing, if you're referencing an array, there was a temporary variable associated with that. Just make it be an R-based variable. And that's all you got to do is change that prefix in those two places. And you're set. It'll come out later. Like this will be this way, but it'll be set.
Okay, thank you.
Anybody else? And like I say, I always stay after class. So if you need to go, Philip, you can go. And like I said, I'm still recording, so if you want to come back and listen to this later. But anybody else got any more questions for the weekend?
I have a question about syntax.
Yeah. You might have to get closer to your mic, Joshua. I can't hardly hear you, and I even got a headset. So.
Yeah, deal. Can you hear me a little bit better?
A little better, but go ahead and say it, and I'll see if I can hear. I'm not sure if everybody can hear you, but I got headphones on.
Oh.
Oh, my God.
Yeah,
Now
that worked great. It was set to the wrong microphone, so my microphone was on the floor. Okay.
Yeah, it sounded like you were in a tunnel, like half a mile away, screaming. Yeah, that sounds wonderful. Go for it.
Okay, sounds good. So I'm just trying to make sure that my literals and syntax are only stored once in my symbol table. Right now, I'm just using the symbol ID as kind of the key value in my hash table, in my hash map.
Well,
and so I'm not checking the lexem to see if I already have that lexem, right?
No, and so think what you should write. To some extent, I'll write the whole thing down. So let's just take a number. All right. So it probably, starts with an N. It points at this other record. Okay. I know there's more to it. So there's scope, but it's pretty easy to think. P. I can't think of how to spell scope right now. So it's just at G, but you can think of the lexem is just, let's say, a 7. Literally, what you need to do is, and you don't have to write it to be fast. So don't worry about being fast. But if you've used a data structure that implements this, which you probably have, you've got a way to iterate. There will be an iterator, every language I know of, to where you can iterate through the value side. Do you know what I'm talking about?
Yep.
Iterate through the value side, and just for the lexem, look for that 7, and you might go, but I'll iterate through everything. Don't worry about being faster. Really. Yeah, I can explain ways to do it faster, but the honest truth is your compiler is going to work more than fast enough for you, even if you don't write it to be fast. And I would go, if you want to go back and make it fast, then worry about it, but just iterate, because you can think of, then this will be a lot of the same thing you can use when you get doing iCode, because then you'll go through and say, I'm looking for a certain lexem, but I'll also be looking for the certain scope. And yeah, there's ways to optimize it. I used to talk about it, but the truth is too many students felt like they needed to do it. And the truth is all you got to get is the I exists and the R exists. And so you can say, you'll iterate through these things on the other side. I've never seen anybody's compiler be so slow. It's like, I can't compile your code because your symbol table lookup is too slow. So don't worry about optimizing it.
Okay, cool. I was just making sure I wasn't missing something, or if that was kind of the right way to go.
If that's what you're doing, you're not only good, you're great. All right?
Cool. Sweet. Thank you very much.
Anybody else? Anything else? And like I said, it doesn't have to be on any portion. Travis, you got something?
Yeah, I'll call you after class just to pass off that thing after main we talked about.
Okay, yeah.
So I'm just reminding you.
Yeah, thank you. Yeah, no, I'm not going to go anywhere. I might have to go to the bathroom right after work, but just call me as soon as we get off. Anybody else need any help on anything? Or if you want to talk to me and it's more private, you don't want anybody else to hear, just call me as soon as I get off the call. But I can tell I do have to go to the bathroom, so give me at least a minute to make it to the bathroom before I come back. All righty? Everybody who's still left, have a really nice weekend. I will tell you, it was a wild week for my middle son. If you didn't hear about the Breonna Taylor verdict, he works in a hospital. He is an emergency room surgeon, and one of the police officers that was shot, he got or had to work on, but it's made him pretty sad being there because he's seen so many, unfortunately, black young men come in that have been beaten or shot that he's been working on over the last few months since this has gone on. So me and his mom have been talking to him and hoping he stays safe because, yeah, that's becoming a crazy place. Maybe not in the reasons you think of, but yeah. Hey, bye-bye. I'll talk to some of y'all in just a minute.